Med-Decode. Welcome to Med-Decode. Today we're doing a deep dive into something that's, well, it's shifted from just being an environmental issue to a really personal biological one, microplastics. And their, frankly, disturbing connection to our health. We all know plastic is convenient, right? Great containers, strong materials. But what happens when all that stuff breaks down into tiny, invisible pieces that get into everything? What we touch, breathe, and, eventually inside our bodies. We've got some key sources here, including a really significant JAMA Insight article and some related research on neurological and cardiovascular effects to unpack.
Yeah, and for you listening, the whole conversation around plastics has really changed. It's gone way beyond just, pictures of plastic in the ocean. Now we're actually finding these particles inside us in really sensitive human tissues. So our mission today is to cut through the noise, the huge amount of data, and understand the how. How do they actually cause harm? What are these particles? How do they get inside us? And what's the science starting to tell us about the potential risks? The goal here is knowledge, definitely not panic.
Okay, let's get into it. To really get a handle on the microplastic issue, we kind of have to zoom out first, right? Look at the big picture, the sheer amount of plastic being made.
Exactly. It's sort of the origin story of this whole problem. Plastic production is just booming globally.
Yeah.
Total production hit 435 million tons back in 2020.
435 million tons.
Yeah, and what's really striking is that figure had almost doubled just since the year 2000.
Doubled in 20 years. Wow.
Right, a massive jump. And it's not slowing down. Projections show it could increase another 70% by 2040.
70% more. So we're basically living in a plastic age, and all that plastic breaking down just guarantees more and more microplastics. It's inevitable.
It is. And, the problem isn't just the plastic polymers themselves, like the polyester in clothes or polyethylene in packaging. The sources we looked at point to a double threat.
The additives.
Additives. You mean the chemicals they put in the plastic?
Precisely. There are something like 13,000 chemicals associated with plastics, but researchers are focusing on about 10 main groups that are real health concerns. Okay, so which ones should we be aware of? The big players.
No, it's often the usual suspects, but in this new context, we're talking flame retardants, PFAS, those forever chemicals for water resistance, phthalates that make plastics flexible, and bisphenols like BPA. The worry is twofold. They can be toxic on their own, and crucially, they can leach out of the plastic. Especially as the plastic breaks down into smaller pieces, they migrate into us.
So it's not just the physical particle, but the chemical baggage it carries or releases.
Exactly. That chemical leaching is a really important part of the story.
Okay, so let's zoom back in. From the huge global problem to the tiny little enemy. We hear microplastic all the time. How small are we actually talking? Can you make it relatable?
Sure. Technically, a microplastic is any piece of plastic smaller than 5 millimeters, so smaller than a grain of rice. But the real danger zone seems to be at the really tiny end. Particles less than 0.1 microns, that's nano-sized. Super, super small.
And these microscopic bits have two main ways into our bodies, right? Breathing them in and eating or drinking them.
Correct. Inhalation and ingestion. And for inhalation, size is critical. When these particles are 2.5 micrometers or smaller, that's the PM 2.5 category we already worry about. With air pollution, they can get deep into our lungs.
Right down into the alveoli, the air sacs.
Exactly. And from there, the really small ones can potentially pass through the lung tissue itself and actually get into the bloodstream.
Into the blood, which means they can travel anywhere in the body.
Potentially, yes, including, concerningly, crossing the blood-brain barrier.
Okay, that puts the danger in perspective. But what about ingestion? How common is that? Is it just like from obvious plastic packaging?
Well, the exposure is maybe more widespread than you'd think. It's not just industrial pollution out there. It's in everyday things. The sources give some pretty surprising examples. Like a 2020 study looked at 57 common drinks, sodas, beer, iced tea, energy drinks.
What did they find?
They found microplastics in 48 out of the 57 beverages tested.
Wait, 48 out of 57? That's almost 85% contaminated? Good grief. Which drink had the most?
Actually, it was a beer sample. It had the highest average, around 28 particles per liter.
Beer? You wouldn't expect that.
It suggests that maybe standard filtration and processing just aren't catching these tiny particles. And it's not just drinks. Think about personal care products.
Like face wash and stuff.
Yeah. One review found microplastics in about 16% of cosmetics tested, and facial scrubs were particularly high. Over 26% contained microplastics.
So that scrub meant to make your skin healthier might actually be adding microplastics directly.
It's a potential route, yes. Something to be aware of.
Okay, this leads us to a really crucial point you mentioned earlier, how they cause harm. It's not just that they're there.
Exactly. We really need to stop thinking of them as just tiny, inert specks of plastic dust. They're much more active and complex than that.
What makes them active? What changes when plastic breaks down so small?
It's largely about their surface. When plastic breaks down, the surface becomes really coarse and irregular. It has a large surface area for its size. And scientists describe this surface as acting like a magnet, or as you put it earlier, like a toxic taxi.
A toxic taxi, I like that. So the plastic particle itself is the vehicle.
Kind of, yeah. It picks up hitchhikers from the environment. These pollutants stick to its surface, forming what's sometimes called a corona or a halo.
What kind of toxic hitchhikers are we talking about?
Really nasty stuff, potentially. They're great at absorbing, pulling in other environmental pollutants, things like polycyclic aromatic hydrocarbons, PAHs.
PAH? Those are carcinogens, right? From burning fossil fuels, smoke?
That's right, known carcinogens. They also readily pick up heavy metals, lead, arsenic from water or soil they might be floating in.
So when we ingest or inhale the microplastic,
You're getting the plastic particle itself, plus this concentrated dose of whatever toxic chemicals it picked up along the way.
and didn't you say earlier the plastic also leaches its own chemicals? The additives?
Exactly. That's the other punch. So the toxic taxi isn't just carrying external pollutants like PAHs. It might also be leaking its original chemical additives, the phthalates, the bisphenols, directly into your system at the same time.
So it's like a double dose of toxins.
You could think of it like that. You're potentially consuming this toxic cocktail. The plastic, its own leached chemicals, and the environmental pollutants stuck to it. It's complex.
Okay, that mechanism makes the next part even more worrying. This isn't just theoretical, is it? Scientists are actually finding these things inside us.
Yes. That's the unsettling truth. They're finding these microplastics, these toxic taxis perhaps, deep inside human tissues.
And the list of places they've been found is, well, it's a lot. You mentioned the brain.
Yes. The brain, blood, liver, kidneys, heart. Also reproductive tissues like testes and ovarian fluid.
Crossing the blood-brain barrier is huge, scientifically speaking. That points to potential neurological effects.
It certainly raises major questions, but perhaps the most stunning findings relate to exposure across generations. They've been detected in the human placenta, in human breast milk, and even in meconium, that's a baby's first stool.
Plastic in the placenta. That means exposure is happening right from the earliest stages of development, when we're most vulnerable.
That's the implication, yes. And we have some data, although it's limited, suggesting this exposure is increasing pretty rapidly.
Increasing. How do we know?
There's a study from Hawaii that tracked microplastics in placentas collected between 2006 and 2021.
And what did they find over those 15 years?
In 2006, they found microplastics in 60% of the placental samples. By 2021, that number had jumped to 100%. Every single sample tested positive.
Every single one.
Everyone. And not just presence, but the amount increased significantly, too. It went from an average of about 4 particles per 50 grams of tissue in 2006 up to over 15 particles in 2021.
So in just 15 years, detection went from 60% to 100%, and the average concentration nearly quadrupled.
That's what the study showed, yes.
That's not a small change. That's a massive infiltration. It really demands attention.
It does. And while we don't have, say, 50 years of data, these kinds of longitudinal studies strongly suggest that as global plastic production keeps climbing, our internal load of microplastics is likely climbing right along with it.
Which brings us to the million-dollar question. Okay, they're there. They're increasing. But do they actually cause disease? I know science is careful about causation.
Right. Presence doesn't automatically equal causation. That's a crucial distinction. But the associations that are emerging now are becoming very hard to ignore. We already know from lab studies on cells, on animals, that microplastics can cause biological harm. Things like oxidative stress, inflammation, messing with the immune system.
Okay, so we know they can do damage in principle. What about in humans?
Well, there are 2 recent observational studies in humans that have really heightened the concern immensely.
Let's start with the heart study, the cardiovascular one. I heard the numbers were pretty stark.
They were. It was published in the New England Journal of Medicine. They looked at patients who were having surgery to remove plaque from their carotid artery plaque that wasn't causing symptoms yet. They analyzed that plaque afterwards, and they found that patients whose plaque contained detectable microplastics, specifically polyethylene was mentioned.
Polyethylene, like in plastic bags and bottles. Very common stuff.
Very common. Those patients had a 4.5 times higher risk of having a heart attack, a stroke, or dying from any cause within the next 34 months compared to patients whose plaque didn't have detectable microplastics.
Wait, say that again? 4.5 times higher risk of a major event or death, just associated with having these plastic bits embedded in their artery plaque.
That's what the study reported, a 4.5-fold increased risk.
That's a huge association. You just can't brush that aside. Do we know why? Is it the polyethylene itself or the inflammation it causes?
The sources suggest it's likely complex. It could be the physical particle causing chronic irritation and inflammation, making the plaque less stable. The fact that polyethylene was dominant is concerning simply because it's everywhere.
Wow. Okay. And it's not just the heart, right? You mentioned a neurological link, too.
Yes. That's the second really significant finding, this one published in Nature Medicine. Researchers looked at brain tissue after death, and they found that people who had been diagnosed with dementia had significantly higher concentrations of microplastics in their brain tissue compared to people without dementia.
How much higher?
The difference was quite dramatic, something like 6 times higher concentration on average in the dementia group.
6 times higher. So
Yeah.
let's synthesize this for the listener. Lab studies show these particles can cause inflammation. Now, we have human studies linking their presence in arteries to a massively increased risk of heart attack and stroke, and linking higher concentrations in the brain to dementia.
Correct. The picture emerging is that these particles are far from harmless. They seem to be actively interacting with our biology in ways that are associated with some of the most serious diseases we face.
It sounds pretty bleak. Is there anything we can actually do? It feels overwhelming.
It's easy to feel discouraged, absolutely, but it's really important to remember what the experts involved in this research also say. One quote that stood out was, "Don't get discouraged. These are fixable problems."
Fixable. How so?
Well, this is fundamentally a human-made problem, right? Plastic doesn't occur naturally on this scale, so that means human actions, policy, innovation, individual choices can address it.
Okay, that's a more hopeful frame. What's happening on the big policy level, globally?
Things are moving, thankfully, is slowly. We had the Basel Convention amendments back in 2019 starting to control plastic waste moving across borders. But the really big one is the negotiation of the United Nations Global Plastics Treaty. That was signed in 2022.
A global plastics treaty. What's the goal there?
It's ambitious. It aims to tackle the entire life cycle of plastic, not just waste, but looking at production levels, designing safer plastics, improving disposal and recycling. The idea is to turn off the tap at the source, basically.
That sounds crucial. But international treaties take time. What about for you, listening right now? What can individuals or communities do today, knowing that microplastics come from bigger plastics breaking down?
The most direct action is source reduction. It sounds simple, maybe, but just using less plastic overall, especially single-use items, is key. Every piece of plastic avoided is future microplastic pollution prevented. It's about supporting systems and choices that just use less of the stuff.
And what about the long game? Beyond just using less?
That's where innovation comes in. Supporting better recycling technologies, demanding and choosing products made with safer, truly biodegradable or non-toxic alternatives. Alternatives that don't rely on those problematic chemical additives we talked about.
So every choice we make about a container, a product, it kind of casts a vote for the future.
In a way, yes. It influences the market and ultimately could influence the microplastic load in our environment and our bodies down the line.
Okay, this has been a really eye-opening deep dive. Let's recap the biggest takeaways. First, the sheer scale of plastic production is staggering, and it's set to increase another 70% by 2040. Second, this toxic taxi effect. Microplastics aren't inert. They carry and potentially leach harmful chemicals. And third, those alarming associations, particularly the 4.5 times higher cardiovascular risk linked to microplastics in artery plaque. That's huge.
And if we pull back to that bigger picture again, maybe a final thought for you to consider. If we're seeing microplastics increasing so rapidly in the very youngest human tissues, placentas, newborns, what kind of fundamental shift does that demand from us? How should that change how we think about the everyday plastic containers, the packaging, the products we rely on, without a second thought?
That really brings it home, doesn't it? Shifting the focus from out there in the environment right back to our own kitchens, our own choices. We hope this deep dive hasn't left you feeling fearful, but rather armed with the knowledge you need to push for and make necessary changes. Tifakta, thank you for joining the deep dive. Please share this knowledge and choose wisely.
And that's a wrap on this episode of MedDecode. I really appreciate you joining me today. If something we talked about sparked your interest, or if there's a medical term that's been bugging you, let me know in the comments. And if you enjoyed this, be a pal and share it with a friend. We'll catch you on the next one.